AWS Amazon Simple Queue Service SQS. Description: fully managed message queuing service that enables you to decouple and scale microservices, applications, and distributed systems. Prerequisites: AWS account, ing user with necessary permissions to create, manage, and access queues. Use cases: decoupling applications. SQS allows different parts of an application to communicate without direct dependencies, improving flexibility and resilience. Asynchronous processing. SQS facilitates asynchronous operations by allowing tasks to be queued for processing at a later time. Load balancing. Distribute workloads across multiple consumers by queuing requests and letting consumers pull messages from the queue. Message buffering. Use SQS as a temporary buffer to handle message bursts or to bridge applications with different processing speeds. Steps: create a queue. Define the queue's name. Attributes like message retention period, visibility timeout, and message size limit, and access control policies. Send messages to the queue. Publish messages to the queue containing the data or instructions for the processing tasks. Receive messages from the queue. Consumers pull messages from the queue based on their availability. Process messages. Consumers process the received messages and acknowledge their successful completion. Challenges and fixes. Message loss. Messages might be lost during transmission or due to queue failure. Use message acknowledgements. Consumers acknowledge receipt of messages, ensuring that messages are processed only once. Message duplication. Messages might be delivered multiple times due to network issues or queue failure. Use idempotent message processing. Ensure that processing a message multiple times does not result in unintended side effects. Queue throttling. SQS may throttle requests to prevent overload, resulting in message delays or failures. Increase queue throughput. Adjust queue attributes to increase message processing capacity. Use backoff and retry strategies. Implement exponential backoff and retry mechanisms to handle temporary throttling. Message ordering. Messages may not be processed in the order they were sent. Use FIFO queues. FIFO queues ensure messages are processed in the order they were sent. Implement custom message ordering logic. Develop custom logic to maintain message order if FIFO queues do not meet the specific requirements. Message visibility. Timeout. Messages remain invisible to other consumers for a specified duration, impacting message processing efficiency. Adjust visibility timeout based on processing time. Set the visibility timeout to match the expected processing time to avoid unnecessary delays. Use message extensions. Extend the visibility timeout for messages requiring longer processing time. Queue size limits. The number of messages in a queue can be limited, potentially causing message rejection or delays. Use multiple queues. Divide workloads across multiple queues to distribute message volume. Implement dead letter queues. Configure a dead letter queue to handle messages that cannot be processed successfully. Cost optimization. SQS charges based on message requests and storage, requiring efficient resource utilization. Use standard queues for less critical messages. Standard queues offer cost-effective message storage and retrieval for non-critical applications. Use FIFO queues for critical messages. FIFO queues provide guaranteed message order but incur higher costs compared to standard queues. Monitor queue usage and adjust capacity as needed. Regularly monitor queue usage and adjust capacity to optimize resource allocation. Security. Ensuring data privacy and access control is crucial for secure message handling. Using policies to restrict access to queues. Define granular permissions to control access to specific queues. Enable queue encryption. Encrypt messages at rest and in transit for enhanced data protection. Implement security best practices. Adhere to security best practices for access control, authentication, and encryption.